Good afternoon. Everyone's still awake? Because this is the most exciting topic possible for the week, deployment? Not at all. Well, deployment's usually boring stuff. We'll try to talk about some new stuff and make it a little more interesting at least. But this session is Windows 10, what's new in Windows 10 deployment. My name's Mike Niehaus. For the next 75 minutes or so, we'll go over kind of the changes that we're looking at for Windows 10 deployment, some of the new things that we're introducing, and changes to existing tools as well. To start off with that, though, we kind of had to talk about an inspirational goal for us, which is really to get away from the traditional deployment altogether, to move away from the wipe and load that people have been using for the last decade or so, and instead look at other alternatives that can be used to deploy an OS without as much work. So instead of having the traditional deployment, back up the user state, lay down a new golden image, reinstall apps, inject drivers, and then put all the user data back, how can we leverage OS tools to do that simpler? So the first step would be, well, can we use in-place upgrade to go from an old OS version to a new OS version? But then that still leaves the question of how do we deal with new devices? How do we set up a new device so that it's ready to be used by the end user without needing to lay down a new image on it and without having to spend really much time configuring the device? Before we get to that, though, we should talk about just the general app compat challenge, because that really becomes the first big challenge for most organizations looking at a new OS. Will my existing applications work? Will my existing hardware work? Will my web pages work? So we had to start there and talk about just overall what are the requirements and what are the expected compatibility results going to be. From a hardware perspective, if a machine can run Windows 7, Windows 8, or Windows 8.1, it should have no issues at all running Windows 10. We continue to push Windows 10 down so that it can run on lower end hardware. The net result of that is it generally runs better on devices than the OSs before it. So no concerns from a hardware requirement perspective. Anything that runs Windows 7 or above should work fine. There are a few minor gotchas in there. There is a couple of specific CPU instruction requirements for the 64-bit OS that were introduced with Windows 8.1. So if you want to run a 64-bit OS version of Windows 10 on, say, a Pentium D processor, sorry, it's not going to run. How many of you still have Pentium D processors? No, I would hope not, because they're like 8 or 9 years old and they only supported 2 gig of RAM, and I'm not sure why you'd want to put a 64-bit OS on that anyway. So there are a few pieces of hardware that won't support 64-bit OSs. They would support x86, but otherwise everything just works. It's not to say that there won't be the occasional driver that needs to be updated to support the new OS capabilities or to ensure compatibility with the new OS. So we are working with the OEMs and ISVs to make sure that we can address any driver issues that come up. But from a hardware perspective, same CPU requirements, same RAM requirements, same disk space requirements as Windows 7. For application compatibility, we expect this to be a pretty good story overall. For those of you who migrated from Windows XP to Windows 7, would you say that was a smooth experience? I hear chuckles. No, that wasn't a smooth experience at all. That's the worst migration you could possibly go through. This one will be much better than that. For those that went from Windows 7 to Windows 8 or 8.1, the experience was much better because the amount of change in the OS was much smaller. The same is going to be true with Windows 10. Yes, we're making lots of changes to the OS, but the changes aren't really to the Win32 subsystem that these apps run in. So as a result, if you don't change it, you don't break it. So we expect that desktop apps, 90+% of them will have no issues. Now, we could never say 100% will have no issues because we continue to find ways that developers can do creative and sometimes stupid things. So there are always going to be those apps that need to be either remediated or upgraded to support the new OS. Then there's the other side of the equation where maybe the application works just fine, but you need a support statement from the ISV to certify that it's properly supported on Windows 10. We are trying to work with the ISVs to get them moving forward with Windows 10 in that vein as well. So there are still some challenges with that. I've got another session tomorrow, and Chris Jackson has a session as well, talking about the application compatibility challenges, which is as much about the process of verifying that the applications will be okay than it is about really the compatibility problems, because we don't expect there to be too many problems. For those that are running Windows 8 or Windows 8.1, the challenge is with making sure your Windows Store apps still work, the modern applications. But that shouldn't be a big issue at all. We have hundreds of thousands of those in the Windows Store today. We can run automated tests against those to make sure those apps continue to work. So we know when we break things on that side, and we remediate those problems before you even see them. So no concerns there, which brings us to Internet Explorer, which is a challenge. How many of you are running IE11 today on all the machines in your enterprise? That's not a good number. That's probably only a third of the audience. That's going to be the big challenge. Before you can get to Windows 10, you probably should get to IE11, assuming you're running some older IE version. Older versions of IE running on Windows 7 go out of support January 2016. That's not that far away. So you've only got so many months to get from whatever browser you're running today, whatever version of IE you're running today, to IE11 before security updates stop on the older browsers. That's the bad news. The good news is IE11 is the natural stepping stone to Windows 10. IE11, as it exists on Windows 7 or Windows 8.1, will be built into Windows 10. It's not to say that it's the only browser built into Windows 10. We'll also have Microsoft Edge there as well. Edge can be used for the HTML5 internet-facing sites. IE11 can be used for the legacy applications where you need all of the compatibility features that are present in IE. With IE11, we have the enterprise mode capabilities that can enable it to emulate IE7 and IE8. We have the ability to override document types to specify anything from IE5 on up. And we have some reporting tools to help with that as well. So lots of additional investments have gone into IE to make it ready for enterprises to get to IE11 and to use that to support all the legacy apps. Once you get there, the migration path to Windows 10 is relatively straightforward. Now, having two browsers on the system, if you choose to allow Edge to be used as well as IE11, will have some potential user impact on that. So we can bounce from one browser to the other. So maybe they use Edge for all of their normal browsing, and when they hit an internal site, we can say, well, this site needs to run in IE. We can pop up IE to run that instead. So try that out. It's not completely implemented in the current build, but we will be adding more capabilities to handle that multiple browser scenario in later builds. But certainly getting to IE11 on Windows 7 is an important first step to get to Windows 10 and to make sure you stay supported after January 2016. There are several other IE sessions going on. Fred presented a session this morning talking about Windows 10 enterprise browsing, where basically he spent 75 minutes talking about the enterprise mode capabilities and how these types of things will work in an enterprise environment. There are quite a few other sessions going on during the week as well, talking about this from different angles. How do you deploy it? How do you secure it? How do you manage it? All of those topics are covered. There's a question back there. Sorry, I can't hear that. So if you can grab a microphone, that would probably help.
Windows 8.1 was that people would pull up the Metro browser, save a bookmark, then they'd go into the desktop version and go, where's my bookmarks? Is right. IE11 and Edge going to have different bookmarks and that kind of thing?
Yeah, at the present point in time, they don't. That's still something being discussed, but at this point, they have separate browser histories, they have separate cookies, they have separate shortcuts. That's not to say that that can't change, so if that's important, certainly submit some feedback through the Windows feedback tool, and we can look at the potential for that. So lots of discussions around IE 11. We need to get there. We need to enable that in order to get to Windows 10. For those that think, oh, well, I'll go to Windows 10 first, and that will get me to IE 11 at the same time. How many of you think you can get to Windows 10 in your entire enterprise by January 2016? If so, we'd like to do a case study with you, because that will be record speed for an organization. That's very fast. If you've got lots of machines, getting that number of machines through all the testing, all the compatibility, all the ISV support statements, and through just the physical process of deploying the OS by January is a really tough thing to do. Those that are running Windows 8, not 8.1, are kind of in the same boat, because Windows 8 goes out of support in January 2016. So if you're running Windows 8 today, you have a choice. You can go to Windows 8.1, or you can go directly to Windows 10. But it's the same problem. You need to finish it by January 2016. So if you have a choice between moving to Windows 8.1, which has been out for quite a while and is fully supported, or going to Windows 10, which isn't out yet and will probably take a little bit before all the ISVs sign off and say, yeah, I'm ready to go, it should be a fairly obvious decision on which direction you need to go. How many of you are still running Windows 8? Fortunately, that's a small number, so not a big deal there. So let's talk more about the deployment choices. Traditional wipe and load's been around for quite a while. Everyone understands this process. They've been using it with MDT, with Config Manager, where you capture the state, lay down your golden image, inject drivers, reinstall all the applications, and then put the state back. That's still an option. Will work just fine with Windows 10. We'll update all of our tools to support that. But we want to add new scenarios, like in-place upgrade. Behind the scenes, in-place upgrade works pretty much the same way, except Windows is doing all the work. So it automatically captures all the data and settings from the OS, but in addition to that, it captures all the drivers and all the apps. So it effectively grabs anything that's not part of the OS, moves it off to the side, lays down a brand new clean operating system, and then merges all of that back in. It's a fairly quick process, fairly efficient process, takes about an hour and a half on most systems. And the end result is everything's preserved. All the applications are still there, all of the drivers are still there, all the data and settings are still there. Question?
We tried that in Win 8. It seemed like a pretty small percentage of various combinations we have actually were supported for it. Has the ability to do that been significantly increased with Windows 10 over what was available with Windows 7 to Windows 8?
Yeah, so the question was, well, we could only do that in some combinations. Has that been improved in Windows 10? It's been improved for the OS versions that are supported. With Windows 7 to 8, you could only do 7 to 8. You couldn't do Vista to 8 or something like that. You couldn't do XP to 8. You could only do N-1. So with Windows 10, we'll expand that to include all the OS versions, 7, 8, or 8.1. That's the easy part. The harder part is more significant changes, like x86 to x64. There's a lot of people that deployed x86 versions of Windows 7 and now look at it and say, yeah, I'd like to go to 64-bit Windows 10. Can't do that via an in-place upgrade. You'll have to do the traditional wipe and load to pull that off. There are other scenarios that won't work too, like Windows to-go sticks can't be upgraded, boot from VHD can't be upgraded. So there are some other scenarios where in-place upgrade doesn't apply. The one that's still a little concerning to us and one that we're still working on is with third-party disk encryption tools. Today, if you're doing an in-place upgrade on a machine encrypted with BitLocker, Windows knows how to deal with that. It suspends the BitLocker protectors, does the in-place upgrade, turns BitLocker back on the other side. Everything's happy. Try that with a third-party disk encryption tool. It reboots to go into the next phase of the upgrade process, which starts from a Windows PE environment, and generally blue screens at that point. So we're working with the third-party disk encryption vendors to try to come up with processes that they can hook into the upgrade to make sure that that whole end-to-end process works. So certainly there are scenarios where in-place upgrade isn't an option, but for the bulk of machines, when you're keeping the architecture the same and going from 7, 8, or 8.1, you can get to Windows 10 without issue. We'll talk a little bit more about that in a minute. But the third choice then is the provisioning scenario, where we want to be able to take a new device and transform it into an enterprise device. That can include changing the SKU of Windows from Pro to Enterprise. That can include installing apps, applying settings, even adding data files to that image. All of that can be done using a provisioning package. So we have new tools to create these and new capabilities to apply them. That's really to support new device scenarios and probably for more like the choose-your-own-device scenarios, where you want to enable your employees to be flexible and choose whatever type of device they want. But if you try to do that in the traditional manner, trying to get the drivers for potentially hundreds of different models of machines is just not workable. If you do this where you just keep the OEM image on the device, remove the extra stuff, add your enterprise configuration on top of it, it's practical again. You can turn that device into something that can actually be useful. That's not to say that you may look at it and say, yeah, we could do that, but it takes just as much time to do that as it does to just deploy a new corporate image to the device. If you have well-managed small set of models in your environment, that's going to be completely true. So it becomes a question of trade-offs. Where do you want to spend your time for these new devices? Do you want to make sure that you can get all the drivers and then do the traditional deployment? Or do you do a provisioning approach and use the build that the OEM has put on? So try it out, see what it can do, what it can't do. There will be limitations in the initial release, but you can try it out just to see how well does it fit with what you do in your environment. So let's look a little bit more at in-place upgrade then. It is what we're recommending for enterprises to at least consider. Now, you're going to be skeptical, we understand that, so you need to try it out on some machines to make sure that you have a certain level of comfort with it. You need to make sure that the end result is a system that works reliably, that it's clean enough, that it performs well. So try it out on a group of machines. They can be running any of the supported OSs, 7, 8, 8.1. You would deploy it to the machines using System Center Configuration Manager, MDT, or even manually to run an automated process, setup.exe with a bunch of command line options. So that's what you do to initiate it. Once it's initiated, it uses the standard install.wim. It doesn't use your custom image, primarily because that image can't contain apps. The upgrade process extracts all the apps from the existing OS. It pushes all of those apps back into the new OS. If there were apps in the new OS, it would then have to merge those applications together. The odds of that working are very low. Let's say you have an existing machine with Office 2003 and an image with Office 2013. If those were to be merged together, you'd have two versions of Office on the same machine. Registry keys, files, everything else would collide. The odds of any one of those versions of Office working after that is pretty low. So the requirement is you use the install.wim off of the original media. You can install hotfixes into it. You can inject those. You can add drivers to it if you want, but there can't be apps. We need a clean OS with no applications because we have no way of merging those applications on the fly. The other big thing is it needs to be reliable. So when you install the OS doing a wipe and load, most organizations, if they work at it, they can get to a point where they have about a 97% success rate. 3% failures can be caused by hardware issues, network issues, just other random events that cause the process to fail. What we've seen internally with our Microsoft IT organization is a similar success rate doing in-place upgrades. Still about a 3% failure rate for the same basic reasons. There are just glitches where things don't go right. The difference is what happens when a failure occurs. If you have a traditional deployment pushed out via Config Manager that fails while the image is being applied to the disk, what are you going to do? The machine is going to be left in a state where it might not even boot. It has user data sitting in a protected folder on the drive. It has no operating system. It can't boot. The only thing you can do is send a technician out to the machine to try to piece it back together again. That can be a painful process of manually installing an OS on the machine, manually recovering the user data back into the right place, and then handing the machine back to the user. That can take a couple of hours for a good technician. That could take all day for a more average person to try to pull that off. And more often than not, they're going to have issues doing it, and they may lose some things as a result. In the in-place upgrade, if there's a failure anywhere along the line, the system just rolls back to the old OS. That rollback process is nearly bulletproof. We have almost no issues reported for that, and every time we do see an issue, well, we fix it and make sure that it never happens again. I mean, the types of testing we do on this are pulling power plugs and holding down the power button and injecting drivers that cause the thing to purposely blow up at random points in time. So we make sure that wherever the failure occurs, we can recover and roll back to the old OS. So the worst case scenario with those 3% failures is you go back to Windows 7. No big deal, the end user logs back in again, they're still productive on Windows 7. Config Manager notifies you that, hey, oh, by the way, this task sequence failed. You can take a look at the log files at your leisure, try to figure out what went wrong. Maybe it was environmental, maybe there was an incompatibility found with a particular driver or an app. You can remediate that issue, try again later. So it's a much less disruptive process in cases of failures. The biggest concern that most customers end up having with this isn't about how long does it take or how reliable it is with the rollback, because you can prove that just by running through this and testing it. The bigger concern is, what does the end result look like? Is the OS going to perform as well? Is it going to be as stable? Are the applications going to work? Is everything going to be as good as if I did a clean install of the OS and reinstall the apps on top of that? That's what you'll need to try out for yourself to prove to yourselves that it is good enough to do that. We won't say that it's going to be exactly the same as doing a clean install and then reinstalling the apps, because we know that there are applications that leave droppings behind on the system. There is extra garbage on the system that the upgrade process will carry through to the new OS because we don't know what it is. We assume it must be important to some application, so we migrate it forward. But it just takes up space. Extra files, extra registry keys, they don't really harm anything. We have a clean operating system. We migrate through all the applications. It shouldn't cause any performance degradations. Just a little bit of wasted disk space. So then we've done a lot of testing with this, starting really seriously with Windows 8 to Windows 8.1. And it's always been supported for previous releases as well, but it was primarily a consumer thing, so it wasn't tested that much in enterprise environments. But with the rapid release between Windows 8 and Windows 8.1, the customers that deployed 8 wanted an easier way to get to 8.1. So a lot of customers did try to go to 8.1 using in-place upgrade, and were fairly successful at it. We even worked with the customer who wanted to upgrade from Windows 7 directly to Windows 8.1, which isn't technically supported, but we thought, well, this is interesting. If they're willing to do that with thousands of machines, we're game. Here's a hot fix. Apply this hot fix to your media. It'll enable a Windows 7 to 8.1 upgrade we'll work with you to do this, and we'll gather some intelligence as a result to see what do we need to change for Windows 10. So based on the results from that, we submitted a bunch of design changes to Windows 10 to say, okay, we need some new command line switches, we need some new options for migrating drivers, we need to work with ISVs on third-party disk encryption tools, we need better logging, we need to fix these shortcomings in the current Windows 8.1 upgrade so that Windows 10 is that much better. So we've already done that. They're all built into the system, and we're not even stopping there. We're continuing to invest more in the in-place upgrade process to make it better as we move forward. So let's try it out just to show you what this would look like. And I'll switch over to my machine here. First, let's look at it from a configuration manager perspective. So I have a Windows 7 machine. It's been customized. It has desktop icons, custom backgrounds, pinned shortcuts, all of the typical items that you would expect. All of that's going to be migrated automatically by the setup process. And all I need to do is initiate the upgrade. This is just a standard configuration manager task sequence. In this case, I'm running System Center Configuration Manager Technical Preview, the vNext one that came out this week. So I can select the task sequence to do the upgrade and initiate the installation. Yes, I know I'm installing an OS. It will download all the bits to the local machine, which it's already done in advance here, and then it kicks off the upgrade. Now, Config Manager, because it's in control of this whole process, hides the entire upgrade UI. So you don't see the blue screen, you don't see anything during the process in the old OS. Once it reboots into Windows PE, you will see the progress dialog as it continues on through there. But it looks like a traditional refresh from an end user perspective. If we look behind the scenes, we can actually see that, eventually after it downloads the bits, that setup.exe will be running. We won't see that yet because it hasn't gotten that far. But as soon as it finishes downloading, it will kick that off. But if you're familiar with the Config Manager OSD executables, you'll notice that there is a new one here, OSD Upgrade OS. There's a new task sequence step built into the vNext preview that includes this to drive this upgrade process. So that's what it looks like for Config Manager. We'll check back on that one in a little bit. Let's do the same thing with MDT. With MDT, we just initiate MDT the same way that we normally would. By running lighttouch.vbs and then choosing a very similar task sequence. This task sequence pretty much does the same thing. It checks to make sure that the machine meets the minimum requirements for disk space and CPU speed and all that good stuff, which shouldn't be an issue. And then it initiates setup.exe to perform the upgrade. So I can choose the task sequence. Need to give it a path. And kick the process off. Now, MDT doesn't do the download initially first. It just runs the upgrade directly from the file share. So where Config Manager was waiting for the download to complete, this one's already running setup. So if we look in Task Manager here at the processes that are running on the machine, we'll already see the setup processes running here. Setup.exe, which is the main executable that's being called, which then runs setup prep launches setup host. So those three processes are driving the whole upgrade experience. If you've ever done a consumer upgrade, the consumer upgrade works pretty much the same way, except it doesn't run setup.exe. It just talks to setup host directly. The Windows Update control panel knows how to launch setup host with the right command line options to drive the upgrade that way. So the consumer experience is definitely different. They're initiating it from Windows Update. The enterprise experience is always going to be you get the media, you add it to a software distribution tool, and then run the automated commands to initiate this yourself. So you're in full control. The other question that tends to come up then is, well, how do I block that? Because, well, maybe I've got Windows 7 Pro machines that can talk to Windows Update. I don't want any random machine upgrading to Windows 10. So we will have a few ways of doing that. One is there's a Windows Update that actually updates the Woo agent to enable the upgrade. You don't have to approve that one, although we would recommend it because it contains other fixes. The second is there'll be a group policy that you can set to say don't show the in-place upgrade. And third, if you're running an enterprise SKU, you won't see it all together because we won't offer an enterprise SKU upgrade via Windows Update. You'll have to deploy that using this type of a mechanism. The question back there. Yeah, so the question is, can the end user continue working? They can, but I'm not sure that we would really encourage it. This is going to be hitting the disk really hard, so their performance is going to decrease. So they're probably not going to be too happy if they continue working. That said, I routinely do that. I keep reading email, I keep doing other things, waiting for the eventual pop-up to come up to say, your machine's now going to restart. And then I walk away and go get a coffee or go to lunch or whatever happens there. So you can keep working. It's not like it's going to cause any issues, but certainly the performance on the machine is going to be impacted. So that'll continue to run. Let's see where the config manager client has gotten to at this point. It's probably at about the same point where let's see if it's finished downloading. Yep, it's finished downloading, so it's now running the same stack of processes, setup.exe, setup prep, setup host. Using quite a bit of CPU too. It's hitting 85% of a single CPU in these virtual machines, so it's definitely pounding away at this system. There is a session later this afternoon. I forget exactly when that session is, but it'll go into much more depth on just exactly what happens during this in-place upgrade. You'll see the basic process. Let me switch back to the other machine. You'll see as we just click through this quickly that it will run the task sequence, which is what we were looking at before. It will then reboot into, apparently I'm too far away. It will reboot into the Windows PE environment, which enters the second phase where it's basically in the old OS is not running, the new OS is not running. It can do some manipulations then to shuffle things around. It can then shift into a third phase where the new OS is up and running and it can just inject the apps and data and settings back into the OS. And then it enters a fourth phase where now everything is up and running and can fully be able to log the user on and continue with the use of the new OS. The end result then is we have everything preserved as before. All of our pinned icons, all of our desktop items, all the data, all the backgrounds, everything is preserved through the process. And of course, this is Windows 10, so we get the start menu back. So the session, it's actually Thursday, on upgrading to Windows 10 in depth. Aziz from the Windows setup team is going to basically walk through every phase of that process and tell you, here's what happens in the old OS, here's what happens during that first boot in Windows PE, here's what happens in the next boot in the new OS, here's what happens in the third one, here's how the rollback works. So all of those details will be explained in that session, which is really just intended to give you a better feel for what's happening so that you don't think that it's just magic, that you have some understanding of what's going on behind the scenes. So let's talk about provisioning then. Provisioning is for enterprises focused on this new device scenario. There are other scenarios that this tool can be used with, but those are more OEM focused. OEMs want the ability to create media that can be blasted out to tens of thousands of machines without modification, and the goal is to shave off seconds from that performance so that their factory floor is that much more efficient. That's not really the enterprise use case. The enterprise use case is, how do I take a new device that I've just unboxed and turn it into something useful? So we want to enable that. We'll have a new tool for authoring a provisioning package, and then a tool built into the OS to apply it. We already talked about some of the things you could do with this, like changing the SKU, installing apps, applying settings. So all of that can be done. This is basically a mechanism built on top of the MDM support that's in the OS. So Windows 10 includes an MDM agent. Provisioning packages are basically offline MDM instructions that get fed to the OS. The OS processes them and applies those settings and apps and everything else to the OS. The tool that we use to do that is the Windows Imaging and Configuration Designer, which is a little flaky in the current builds. So there are lots of things that don't work, but we're still working on that. Hopefully the next public preview will fix a lot of those. But the idea is that you can create a provisioning package, you can give it a name, you can specify whether it's specific for phones or whether it can be used across devices. So these tools don't focus just on the desktop, they also work just fine on phone devices too. You could import one, maybe you wanted to start from a baseline and add some more to it. We don't need to do that. But then we can see all the things that we can do, like adding applications, adding drivers, adding language packs, Windows components, Windows updates. All of those items can be imported in. The end result is all this stuff gets bundled together into one file that can be copied to a system and executed on that system. The settings then allow you to do the typical things that you would expect via group policy or MDM. You can turn off hardware features, you can disable apps, you can configure just about anything in the OS that you could configure via Intune or AirWatch or Mobile Iron. So you get those types of capabilities just self-contained within these provisioning packages. So after we've configured what we want, we can say we want to build the provisioning package, and we can write that out to a location. The one other thing that I wanted to mention here is this upgrade edition product key. That's how we can change the SKU of Windows. So we can put in a key for Windows 10 Enterprise, and when we apply that provisioning package to a Pro machine, it changes it into Enterprise, and then just reboots the machine, and now you're running Enterprise. So that works out pretty well. The product key that I typed in there, don't worry, I'm not giving you the super secret product key. I'm giving you a setup key for Windows 10 Enterprise that can't be activated. So after doing this to a machine, it's going to seek out a KMS server to get activation. That's probably what you want when you're running Enterprise inside of your organization. If this is maybe something you're initiating on a remote machine, instead of putting in a setup key, you'd put in a MAC key. That MAC key could then be activated over the internet. So some options there on product keys. So we build the package. That gets written into a particular location. We can encrypt it if we want. We can put a password on it. We can sign it with a certificate just so that it can be verified as trusted by the organization. And finally, it gets written to disk, where we can then copy it to any system where we want to use it. Now, built into Windows 10, we basically don't have any way to distribute these. So you'd put it on a USB key or attach it to an email message or inject it into an image or something like that to get it to a device. But we are looking at other things that we can do longer term to make it more automatic to get these out to systems. So we then take that package and copy it over to an a Pro machine, because we want to change the SKU. So here we've got a Pro machine. This Pro machine has the provisioning package copied to it already. We can initiate the, we can initiate it just by double-clicking on it, which I would do live if it didn't take so long. It takes about 5 minutes to go through this end to end, but if we do it with the video, we can chop out the boring parts. We double-click on it, accept that we want to apply it, accept the prompt for elevation because it's making a machine-level change. It needs to have elevated rights. It then initiates a reboot. It installs all the enterprise features, and after it's done doing that, you can log back in, and now it's running enterprise. So it really is that simple. That's using a provisioning package. You can do the same thing via mobile device management. So let's say you have a device enrolled into Intune. You can put your product key into Intune and tell it to push it down to devices, and it'll upgrade them to enterprise. There's even capabilities to expose these settings via WMI. So you can run a PowerShell script that creates a WMI object that pushes the values in the same way using a WMI bridge. So all kinds of nice capabilities to leverage that inbox MDM support, even for systems that aren't being used with an MDM service. There is another session talking more about the MDM capabilities that Janani's doing. So if you want to know more about the inbox MDM and the architecture around that and how this layers on top of that, check that out. There's another session that Vlad is doing talking about provisioning packages and more details around that. So that would be the one to dig in deeper to these provisioning tools and all the different types of things that you can do. But to summarize, we want to be able to transform a device, change it to an enterprise SKU, install apps, apply the enterprise configuration, and most importantly, bootstrap the device into a management service. This really isn't designed for ongoing management of a machine. It's designed for initial configuration. You want the initial configuration to get the device to a manageable state, and then after that, the management tool takes over. To help with that, the Intune team's been looking at creating provisioning packages from their web page. Like click a button on their web page and download a provisioning package that when you run it on a client, it enrolls the device in MDM. So you don't have to give the user instructions on click, 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 type in your ID and password, now you're enrolled. Instead, you just say, double-click this file. Off it goes. So that's the type of scenario that they're looking at, to be able to bootstrap the device into a mobile device management solution. Initially, there'll probably be some limitations, like we probably won't be able to run scripts or Win32 installers or MSIs or things like that. That's probably going to come a little bit later, but initially we'll be able to do modern apps and the little language packs and updates and the other things that we looked at. So it may have some challenges around, say, bootstrapping a device into Config Manager, but it will be able to bootstrap a device into Intune or any other MDM service. Initially, we'll be able to do this from media by copying the file to a system via an email message, whatever. Longer term, we want to automate this so that you can trigger this from just connecting it to the corporate network, joining a domain, joining Azure AD, doing these other types of activities that then trigger the installation of a provisioning package. The provisioning session that I mentioned before that Vladimir's doing is Thursday at 10:45. He'll spend 75 minutes talking just about Windows ICD, the provisioning tool that works behind the scenes, and what these provisioning packages actually do and what they look like. Okay, so traditional deployment then. We'll have a new assessment and deployment kit for Windows 10. The preview of that's already out. For those of you who've gone looking for it and can't find it, it moved. It used to be on the Download Center. It's not on the Download Center anymore. You now need to go to the Windows hardware development site, like dev.windows.com. There's instructions on how to find it that Aaron had posted to the MS Deployment blog. So easiest way is to go to blogs.technet.com/msdeployment. The most recent blog posting there talks about using MDT with the latest builds and has the instructions on where to go to find the ADK. If you can't find it, let me know. We'll point you to it. So it is out there. We released an updated version last week to correspond to the 10074 build of Windows 10 that was released. Although the ADK version is 10075. Don't worry, it'll work just fine with the 10074 bits. It's a much longer story on what's going on there, but the end result was the ADK version number got bumped by one, even though it's really the same as the 10074 OS. So you got a new ADK. The new ADK contains that Windows ICD tool that we were talking about before. It contains other updates to Windows PE, USMT, and some of the other tools. Mostly minor changes with some exceptions. We'll talk about that. There'll also be enhancements to System Center. So System Center 2012 will get a service pack to support Windows 10. System Center 2012 R2 Configuration Manager will get a service pack to support Windows 10. Configuration Manager 2007 will get an update to support Windows 10. Only for management, not for OS deployment. It won't support deploying Windows 10 just like it doesn't support 8.1. So you will need to apply updates to System Center to support Windows 10, but they're not major updates. They're literally the next finish type of service pack. MDT will also be updated. There's a preview version of that available now, MDT 2013 Update 1. The preview for that is on connect.microsoft.com. If you haven't grabbed that yet, sign up for the Configuration Manager Connect site. That will have the download for MDT as well. When you actually look, though, at the traditional task sequences in MDT or in Config Manager, there's really no difference between the ones that you're looking at for Windows 7 and Windows 8.1. The changes are really behind the scenes. The biggest changes in the MDT case especially is to deal with the change of the Windows version number. Windows changed from 6.1 to 6.2 to 6.3 with Windows 8.1. Initially, it went to 6.4 for Windows 10, but then with the latest preview releases, it changed to 10.0. It also went from build numbers that were 6,000, 7,000, 8,000. It jumped to 10,000, which broke all kinds of things with MDT because it was doing string comparisons on the version number. Is the version number greater than 6.0? Well, 10.0 is not greater than 6.0 when you look at it as a string. So no, it then assumes you're deploying Windows XP. I'll do things differently. I'll look for a cab file that contains sysprep.exe. I'll do all kinds of weird stuff with INF files and old answer files like unattend.txt. Nope, that's not right. So we had to fix a lot of the scripts for Windows 10 to do the proper version number checks. We missed a few in the initial MDT 2013 preview. We knew that this was going to happen, so we tried to fix the issues ahead of time. But the few that were missed are updated in that same blog that Aaron posted. You can just download new scripts and overwrite the ones that are currently there. That's not to say we had found all of them at that point in time. We just found the most critical ones, like you couldn't capture an image using MDT. It would blow up. With the updated scripts, that'll go through. But there are still some other lingering issues. We'll get those addressed before the release just to make sure that we don't have any more of those hanging around. Overall, the process is unchanged. Question? Yeah, the question was about the unattend.xml in MDT 2013, if it was still using the Windows 7 version. And it did, but that only sometimes caused problems. It caused issues if you put IE11 into the OS or if it was already in the OS, because there was one entry in the unattend.xml to hide the welcome screen that was no longer valid. So you had to take that entry out. You also had issues that if the if the machine had a wireless adapter, it would stop in the middle of the UBI process and ask you to connect to a wireless network. So you had to put in a setting to say hide the wireless screen. So there were some tweaks like that. That was actually just an oversight. The MDT had an unattend.xml that was used for all OSs. And then it added a new one for Windows 8, but it didn't add a new one for Windows 8.1. Well, when it couldn't find the one for 8.1, it dropped back to the All OS version, which had those issues. But those should be addressed in MDT 2013 Update 1 because, well, that's easy enough to handle. But if that doesn't work right, then, yeah, let us know. We can take care of that one. It's an inconvenience. Yeah, you can figure that out. So no real changes to the deployment task sequences. You should be able to drop in your Windows 10 media, add it to a new task sequence, and go. If you were to compare the Windows 10 task sequence against a Windows 7 or 8.1 task sequence, no differences, exactly the same. So no big structural changes required there. So we already talked about new tools, the new Windows ICD, updates to the user state migration tool. As far as supported OS versions go, USMT supports capturing from Windows Vista and above and restoring to Windows 7 and above. The goal with the new ADK is to support all the OS versions that you currently have. The one exception would be if you're still running some Windows XP machines, the ADK is not going to support migrating from Windows XP to anything newer than that. We're still looking at some potential workarounds for that, to use an older version of USMT to capture from XP, and then a newer version to restore to Windows 10, just like we did before with Windows 8.1. But if you're still running XP on some machines, my condolences. So we have the new USMT. It does have some new capabilities, which sound rather odd. ScanState has some new command line switches. Those command line switches enable you to capture a provisioning package from an existing machine containing the apps and or drivers from that machine. So why would you ever want to do such a thing? Well, it ties into some changes that we'll talk about in a minute, where we've changed the recovery process for Windows. Now when you do a reset of the OS, it doesn't have a recovery image. It just has the side-by-side store from the current OS. The current OS side-by-side store is the Windows System32 SXS folder. That contains all the raw components for Windows. It will reconstruct the OS from those files. So imagine an OEM ships a system that has all of their OEM stuff, including drivers and apps and everything else they want to add in, and then you reset the PC. All of that would go away because it's not in the side-by-side store. So there needs to be a way to put all that back. So these ScanState switches are designed for OEMs to be able to capture provisioning packages that can be inserted onto the machine to put those back anytime you reset the machine. The question then becomes, well, can you use these in an enterprise environment? And maybe, but we're still trying to work through some of those scenarios to say, is that a useful scenario for you to do? Is there a reason that you would want to do something like that? There are also then new commands added to DISM to apply those provisioning packages and to add them into an image, and a new capability when you're applying a WIM to say, I want to apply a compact OS. We'll talk about that in a minute as well. Basically, the idea is that we want to save some disk space when we apply this to a machine. If you're familiar with WinBoot, this is the next generation. Updates to Windows PE, basically it's now based around Windows 10. It includes the drivers that were included in the Windows 10 payload, so you'll see some changes there, but no real functionality changes in Windows PE. We're still trying to convince them that we need wireless support in Windows PE, but sorry, it's not there in Windows 10. We'll keep working at it. So, Compact OS. How many of you are familiar with WinBoot? How many of you have heard me present on WinBoot? Not too many. A few of you have, but WinBoot was something that was invented in Windows 8.1 to get Windows to run okay on a machine with a 16 gig drive, like these little 8-inch tablets that had 1 gig of RAM and a 16 gig hard drive. Squeezing Windows onto that was rather tough, so WinBoot was created to help with that problem. It would compress the OS into a WIM file. You'd place that WIM file on a separate partition and then create links from the C drive into that WIM file. So the whole OS stayed compressed. There was no sector gap disk space loss. It was as small as you could possibly get Windows so that you would have half of the drive available for you to use. The problem was it was a pain to set up because you needed to set up a separate partition that was just big enough to hold that WIM file, maybe a little bit bigger to hold an OEM customization WIM file as well. And you had to go through this conversion process on existing WIMs to change the compression format and to get it ready for WinBoot. So they looked at it and said, well, the technology and the idea is good. The implementation is just too much work for OEMs to go through. So let's simplify it. So the simplified version is to create the normal one C drive partition. If it's UEFI, you still have a few other partitions. Get rid of the recovery image because that takes up too much space. Use the side-by-side store. But then when you're applying the image using DISM or WIM-GAPI or whatever you're using, just set a switch that says compress the OS as it's being applied. So it becomes magic, basically. How can we just make this as easy as possible for an OEM that doesn't want to worry about the details, just wants the OS to be smaller when it's applied to the disk? So that's what was done. On a 64-bit system, we can shrink it by about 3 gig. So a normal 64-bit install is about 8 gig. When you do it with the compact OS option, it shrinks to about 5. On a 16-gig system with a 16-gig hard drive, that's a fairly significant savings. That gets you quite a bit more life out of that device. So let's look at what WimBoot looks like. Or not WimBoot, Compact OS. If I can get my machine to wake up here. Yeah. So let's look at machines that aren't running right now. Let me save these, get them out of the way. We're talking about systems that only have 16 gig of disk space. My system only has 16 gig of RAM, so running all of these VMs at once gets to be a little bit of a struggle, but we can get them running here. So let's look at a normal one. If we look at a normal system, how many of you have ever installed Windows manually? I have a WIM file, I have Windows PE, I can run dism.exe. Basically, it requires 3 steps. I show 2 of them here. One is to format and partition the disk. That's not too hard. Use diskpart. Second is to apply the image, which you do using the DISM command line. And the third is to run BCD boot to create the necessary boot files and BCD entries for the OS. So you do those steps. The end result is you have an operating system on the C drive. If we do a directory, it's using about 120, it has about 127 gig free on this system. It's a 128 gig drive, and it's basically bytes, but the point is we're going to compare that with another system. So if we look at the command line that was used here, we said dism apply image file, install.wim, index 1 to C:\\. We will then switch to a different system where we've done exactly the same thing with one difference. We added a command line switch that says compact on. That's all it takes. You put compact on this same command line, and now it will compress the OS as it's writing it to the drive. And what it's basically going to do is write the files into an alternate data stream on the disk, which is kind of invisible. You'll never see it. And then creates those same type of pointer files that point into it. So it's the same technology using the same drivers, the same OS capabilities. It's just much more transparent. So if we do a directory of C drive here, we see that we have about 130 gig free. So the difference between the two is about 3 gig on the system. If we were to boot into the OS, we wouldn't be able to tell that this OS was any different than any other. When we look at the C drive there, there's no way to tell that this was even set up with a compact OS. You'd have to go digging into the registry to even see that there was anything different here. The other disadvantage with WimBoot that's been addressed here is with WimBoot, you had this read-only WIM on a separate partition, and then Windows updates would come through. Those Windows updates would update the OS files. It didn't update that original read-only WIM, so the C drive continued to chew away disk space. With Windows 10, when updates install, those updated files get shoved into that same alternate data stream, replacing the existing files that are in there and compressing them at the same time. So Windows won't grow as much over time. It might grow a little because those alternate data streams can get a little fragmented, but basically it's a WIM file behind the scenes. But overall, that means that we can use a whole lot less disk space with a much easier deployment process and keep it from rotting over time. So much better, simpler implementation. The biggest limitation right now is the deployment tools don't support the /compact OS compact on switch. So we're still working on that one, trying to get MDT and Config Manager to add some, at least the ability to put in maybe a variable to define advanced options where you want to enable that. But we'll see what we can get done in that case. Yeah, so the question was, well, what are the other caveats? It's going to have a little bit of impact on the CPU because it's decompressing on the fly. But generally today, CPU is abundant on these machines, so that doesn't impact it very much. It actually can reduce the amount of I/O, which is kind of counterintuitive because it's reading compressed files into RAM and decompressing them. So it's reading less from the disk. Most of the time it's a wash. But with Wimboot, we said, well, we only want to do this on UEFI systems that have 16 or 32 gig hard drives, and we don't want to use it on anything else. With the compact OS, we said, it'll run fine on anything, but it really only buys you something if you're on a small disk system to free up a little bit of extra disk space. If you've got a 250 gig hard drive and you want to free up 3 gig, maybe you should just go buy a bigger hard drive. If you have a 16 gig drive and it's soldered into the tablet that you're using, all right, you want to use this. So we've made it easy, and hopefully we'll make it easier by building it into the deployment tools. The recovery image, we talked a little bit about this. We're getting rid of the recovery WIM itself. We'll rebuild it, no separate partition. More importantly, when we recover the OS, we'll recover the updates at the same time. So you won't have to repatch the OS with the last year's worth of updates. You will have to reinstall potentially a few updates because we'll throw away updates that have been applied in the last month or so. The concern is that maybe you're resetting the device because of a problem the most recent updates caused. So we want to throw those away to give you the chance of fixing whatever that problem was before you reinstall those updates. So we won't do 100% up to date. We'll just get close. But that's certainly a lot better than reinstalling all of these updates. We'll also throw away driver updates because odds are driver updates may have caused the problem too. But we will keep language packs. You definitely don't want to have to reinstall language packs afterwards. That's just time-consuming and inconvenient, especially if you have no idea what the screen says when you're trying to reinstall it. So we will preserve those. Customizations get a little more interesting. Back to that USMT scenario, we want to be able to capture a provisioning package to put those back. So the OEMs, when they ship these machines, should do that. You as an enterprise could do that if you wanted to. Those provisioning packages then automatically get restored as part of the reset process. There are some things that are thrown away, like any installed Win32 applications, any desktop apps that aren't in one of those provisioning packages. Because the side-by-side store doesn't contain them, there's no provisioning package that contains them, they're just thrown away as part of the reset process. We'll also discard application updates that came from the Windows Store. They'll need to be reinstalled, or any newer versions of provisioned apps, they'll have to be reinstalled as well. Not a big deal overall. For devices that are being managed via MDM, we're going to add a remote wipe capability so that you could, via MDM, initiate a reset of the device, which would kick off the same process as if you went into the Settings app and said, I want to reset my PC. So you can do that automatically to recover the machine in case it gets lost. So let's take a minute and look at the USMT switches in case you want to try such a thing. First, I'll tell you that there are some bugs with that as well. Some of the files are missing from the 80K, so I needed to create a folder that contained all of the USMT files plus all of the files from the sources directory on the Windows 10 Media. There's a few XML files that aren't in the right place, so merging those two folders together gives me this USMT folder that contains a whole lot more than what it really needs, but the big thing that's in there is scanstate.exe. So if I run scanstate I can specify /apps/drivers/ppkg, which says that I want to capture the applications, I want to capture the drivers into a provisioning package, overwrite the existing one, continue on errors, and write it out to a ppkg file on the file share. So if we switch over to that server, we can see what that provisioning package looks like. Eventually. So that's a 1 gig provisioning package containing all the apps and all the drivers from my virtual machine. So what apps do you think I have in there? Office? Good guess, but no. I have 2 applications in there. One of them is the Config Manager Toolkit, which isn't very big, and Acrobat Reader, which also isn't really that big. So it's picking up lots of additional changes to the OS that it says, well, they're not part of the OS, but I don't know what they are, so let's throw them in the provisioning package as well. So think of running a packaging tool against an OS and telling it to pick up all the files that have changed since the OS first booted. That's kind of what it will do. It knows to ignore the OS files, but it grabs everything else. If you really want to see what's in that file as a result of doing this, rename .ppkg to .wim, because this is just a WIM file. Mount it and take a look around. It'll show you everything that's inside, so you can see what's been captured. They're still working on that to try to trim out some of the noise, because they know it's capturing things that don't need to be captured, that makes that ppkg file bigger than it needs to be. But it will still likely contain more stuff than what you really want. But it's at least easy to create. So it's easy for OEMs to create this so that the reset process works okay. To put it into the image then, you would go to a machine that's vanilla. In this case, I've already applied it to the disk, but I can run a dism command, and in that dism command, just say to add that provisioning package to the current image. So that's the new switch added there to add a provisioning package, and then I can point to the ppkg file. Now, I'm not actually sure if my capture finished successfully, so this might error out, but it's the same basic idea. I run the command, it applies the provisioning package, which is really just copying it in place on the system, and then if I reboot during the UBI process, it'll find it and say, oh, there's a provisioning package here. I'll make it part of the OS before I get to the login screen. So, not too bad. It finished fairly quickly, and that's probably because all it really did, if we do a directory on the drive, is it copied the file into C:\recovery\customizations. Very long command line to achieve a very simple thing. But if we rebooted now at this point, it would apply that. Unfortunately, that would take too long, so we'll skip over that. But something you can play around with. Hopefully with the next ADK release that comes out, we'll make it so that you don't need to munge together the USMT folder, but there are a couple extra steps to make that work today. If you want to try it and you can't get that to work, just drop me an email. So, MDT 2013 Update 1 then, add support for Windows 10. We'll add a new upgrade task sequence, which isn't there yet, so don't try it yet, it's not there. It adds support for Windows 10, which is primarily the version number changes that we already talked about. It does add support for split WIMs. So if you're creating FAT32 media to use with UEFI systems, it will split the WIM into 4 gig chunks so that it will actually work on media. So that's a nice enhancement. Other than that, it's mostly bug fixes. We're still looking at some other things potentially to add in, so that's not the end of the story yet, but we're still trying to figure out what we can squeeze in before the final release. On Configuration Manager, we already talked about the different versions. Hotfix for 2007, Service Pack for 2012, Service Pack for 2012 R2, and a brand new vNext release, all of which will support managing Windows 10. All but 2007 will support deploying it. They add support for the new ADK, they add support for the new OS, and in the case of vNext, they add a new upgrade task sequence there as well, which is what we were looking at before. Aaron will cover that tomorrow afternoon at 5, where he'll go over those enhancements. There are also some other things being done with Config Manager to simplify driver management and some abilities to say, don't let me accidentally advertise a task sequence to all systems. So if you've ever felt worried that turning your administrators loose on your config manager environment is going to turn all your servers into Windows 10 workstations, go to his session. He'll explain to you how to prevent that. Volume activation is something that you'll need to concern yourself a little bit with. There's no changes in functionality, but like every other OS release we've done, there will be a new hotfix that needs to be installed on the KMS servers and a new key that needs to be installed. That key will support Windows 10 activation as well as Windows 8.1, Windows 8, Windows 7. So you install the one key, the one hotfix, and then you're set to go. On the server side, any server version that currently is supported will work fine with Windows 10. There are no features right now that require any schema updates, so your existing Active Directory should be just fine. WSUS will likely have an update to add support for Windows 10. That's still being confirmed at this point. And there will be some new ADMX files for Windows 10 for some new group policy settings related to Microsoft Edge, to Microsoft Passport, to deploying apps with the new sideloading policies that John Vincel's talking about this week, and a few other minor things that will show up in the provisioning or in the GPO templates. If you're currently running Windows 7 and applying security templates via group policy, please don't apply those same templates to Windows 10 because you'll break things, just as people found when they deployed Windows 8.1 or Windows 8 into their environments. Most other GPO settings are fine, but there are some new security requirements on some of the folders, especially under program files, that you really shouldn't modify the ACLs on those unless you want to break every single Windows app in the system. So be careful with those. Also, related to the version checking that MDT is having issues with, we've seen customers having issues with these because they put WMI filters on their GPOs, saying only apply this GPO if the OS version is greater than or equal to 6.1. Well, guess what? It's doing a string comparison. 10.0 is not greater than 6.1. Your filter fails for the same reason. And wow, your Windows 10 logon times are impressive because none of your GPOs apply. That's what happened to Microsoft IT, and it was glorious while it lasted. They fixed it, and we got all of our GPOs back. There is a session that Samesh is doing this afternoon at 5, talking about just the general infrastructure requirements around Windows 10 and how you prepare for Windows 10 in your environment. So if you want more details around that, check out his session. Overall then, things to consider as far as deploying Windows 10, it depends on where you're coming from today. If you're currently running Windows 7, there's no real urgency to this. We'd say keep on trying Windows 8.1 for tablet and touch-based scenarios. Get to IE 11 by January 2016, and look at Windows 10 at the same time. If you're on Windows 8, you've got a bigger problem. You need to get to either Windows 8.1 or Windows 10 by January 2016. 8.1 is probably the safer bet because you can start now. If you're already running 8.1, you're in great shape with IE and the supported OS. You can look at Windows 10 at your leisure and start the planning process for that. One last thing to wrap up with, the enterprise preview process, the Windows Insider process that we have today, won't go away when Windows 10 RTMs. This continues forever. We'll continue to release new builds of Windows, even after RTM, showing you the progress of new features that we continue to add that will come out with the next update to the OS. So it's useful for you to sign up for the Insider program and start testing these out before they've even hit the real world. You can test them out in your lab. You can set up some machines that are directly on the consumer branch of Windows that get those new features as soon as they're released. You can then have the rest of the machines receive a very well-tested and verified component that you've already provided feedback for well in advance. You can do all of this using the Insider program. We've also talked a little bit about Windows Update for Business this week, which really is designed to enable you to take and put your own rings around this as well and say, I want to deploy these new features first to this pilot group, then to a larger population, then maybe a third of the company, and then let's hit everyone else. So we're trying to provide more structure like that that you can leverage, as well as the insider support and the rings that we currently have in place. So that's what I wanted to go through today, just kind of the broad overview of Windows 10. There were plenty of other sessions called out in there. Hopefully you'll check those out throughout the week. If there are any other questions, come see me up front. Please fill out your evaluations, and thanks for attending.